Alright guys, welcome to day 2 of 121 for Algebra 2. So you should already have your boxes kind of made. We did those the last time. You can still have those for like reference. We're not going to be adding on or building those more, but they're nice to kind of have out to look at and have as a point of reference for us. So what we're going to be starting off today is trying to make a general equation for our boxes. So what I want you guys to do is go ahead and pause the video and try out number 55, where you're going to be drawing a picture of the boxes and kind of labeling the length, width, and the heights. Use all the values which you kind of know. Try and only have one variable, the variable x, and that x should be the height of it. So try and do that, and then use that to write a equation that calculates the volume. Once you think you've got that, or if you get stuck, then go ahead and resume the video and I'll help you out there. Okay, so let's go ahead and take a look at how we can do this. So I have my table there from last time. So I'm going to go ahead and draw out a just general picture of one of our boxes. It doesn't need to be a work of art. We're just trying to kind of have a thing that we can reference, right? So we have our height, we have our width, and we have our length. Okay. So the values which we know, the height is just x. So I'm going to call that x. That's the thing which we're going to change, so it's kind of this value right here. Now, when we did this, right, our width, our original width was 10, right, and then we cut out. If I pull this out, it was 10 across, and we cut out a part on each side. In this case, it was 2, so we cut out 2 here and 2 here, left with 6 there. So it was 10 and then minus 2 and minus 2. And over here, it was 10 and then minus 3 and minus 3. So how we can represent that was that's just always 10 minus 2 x's, whatever that x happens to be. Now maybe your rectangle wasn't a 10 by 15 like the ones that I did was. So you might have a different width number, but same process. It's that original value minus 2 of the x's. Now length, you can kind of probably figure this one out. It's going to be the same idea. My original lengths here were 15. I took out 2 x's, so then I can call my length 15 minus 2 x's. And again, that will be different if your length was different on your rectangle, but we get the point. So now we have our height, our width, and our length for a general box here. So now let's try and figure out, hey, what's the volume in this term? Because the nice thing here is we only have one variable, x, for every single length. So our volume of a general cube or prism is going to be length times width times height, right? So I just got to say this times this times this. So my volume is x times 10 minus 2x times 15 minus 2x. Right? Awesome. So I now have an equation that will tell me the volume of the cube or of the box for any value x that I plug in. Now, at this point, we could multiply this all out and get a polynomial out of it, but there's not really a benefit in doing that. I trust that you all have the abilities to do that, but let's not waste our time doing it if we don't need to. So I'm going to leave it like that for my equation. Okay, that's going to be my general height here. So let's hop back over to this. So we got our general equation for it. Now we're going to try and do some analysis here. So we're going to put this all in a table, and then we're going to graph it and kind of try and use that. So I already have the table which we kind of made. We could expand upon it, but let's just go straight to a graph here. So I'm going to pull up Desmos. And I'm going to actually graph the equation that I found. I found y is equal to x times 10 minus 2x times 15 minus 2x. So that was the equation. So now looking here, here's my kind of default view. Not terribly helpful. I'm actually going to change the color. I think that's just black's not the best color on this, just because it doesn't show up as well on the black and white stuff. Let's do like a green. Sure. Okay. Done. All right. So I'm going to zoom out a bit so you can kind of see this a bit better. It's a little bit weird, but I'm actually going to change the window settings. I'm going to make my x-axis go from 0 to, no, I want it to go from, let's do -1 to like 20. And then our y's we'll do from like -5 to 150. So we can kind of get a better view of what's going on here. So this is the graph that we got, which kind of makes sense. It's a trinomial because we have 1, 2, 3 x terms being multiplied here. So let's figure out, well, what do these variables represent? Because that's probably the most important part at this point. Well, I have a graph. What does that graph actually mean? Well, let's look back at our equation, right? I didn't have y here. I had v, right? I had v is equal to that. So that v is the volume, but over here, it's now a y. So my v or my y is really just my volume. So my y-axis is telling me the volume of this particular box, right? And then the x, as we defined when we first kind of did this, x is the height. So if my height was like 3, I could go to where this is 3, where it hits, hey, there is the volume of my box if my height of the box is 3 centimeters or units or whatever we're measuring here. So if I'm looking for, hey, when is it going to be the most volume possible? And you may look at this graph and say, well, I have this bump here, but more importantly, I got this graph keeps on going way up over here. So I can go super high. I just keep making those cutouts bigger and bigger and bigger. And that's very tempting and is a useful thing, but it doesn't actually work. Let's talk about why that is. So my height and my cutout, and you might have noticed this if you tried to do more of these, once I got to 5, since my rectangle was a 10 by 15, if one of my cutouts is 5, I've now eliminated one of the sides of my box. Now it's a piece of paper that folds in half, right? So my volume became effectively 0. And then if I make my cutout 6, well, now I'm over here and I have a negative volume, which doesn't make any sense, right? Because I've now, on that original rectangle, cut out more than I can on each side, and now I have a negative side length, which mathematically we can graph that, but physically I can't make that. So do I actually care, right? I don't really care about anything beyond this 5 because I physically cannot produce that. So, and then at a point, I end up going back up to being positive. And now what's happening here? This is happening at 7.5. Now what's special about 7.5 on a 10 by 15 rectangle? Well, that's when the length is now 0 because I've cut all of that out. And if I go beyond that, now I have a negative length as well as a negative width. And what's negative times negative? That's positive, right? So once I'm back to being positive on my volume, now I can make it as big as I want, and my value only increases and increases and increases on the actual volume, right? So mathematically, I could have an infinite volume because I have 2 negative lengths, but physically I can't do that. So that's why I only really care about the values here between 0 and 5. That's what I can actually make. Now I don't want 0 or 5 because those are both a 0 volume because it's either a 5 piece of paper or one that's unfolded in half. So the volume that I really want is the one right here at the top. That's the maximum point is what we call it. So that tells me 1.962, 132.038. All right, great, but what does that mean, right? Well, the x value of the point is again the height, and what's the y value? It's the volume. So this tells me, hey, if I make a height of 1.962, I will get the maximum volume for this particular cube or box, which is 132.038 cubic centimeters or inches or whatever we're doing for our unit there. So that's kind of how this works. So we're going to be asked some questions like, hey, what would be a domain that is useful for us? Right? And what would be a range that is useful for us? So on your own, go ahead and pause the video, try to answer these questions on number 56, and I'll come back and I'll kind of try and finish those off. So if you're back now, our first question here, what's the domain? Well, in our kind of process here, our domain is going to be 0 to 5, because that's the domain that we actually care about. Again, we're looking at what is the domain that we care about versus what is the domain of the graph, because the graph has a domain of everything, but I don't care about everything. I care about only the things that are actually going to work for me in the context of the problem. What's the range, and is the range limited? Well, if I look at it, again, just as a graph, this range is everything. But what about the parts that I actually care about, right? My range is from 0 to 132.038, right? I can't go any higher than that and actually have a physical box which I can actually use. So this is, So this is all kind of coming back down to under the context, what do I need? Which is a very key important thing about math is, hey, I care about these things that are useful, not just everything in general because I can, right? All right, so part C here, should we connect the points on the graph with a smooth curve? Well, we've already kind of done that. It's expecting us to have just plotted points as opposed to drawing the actual graph, which we want the smooth graph because we can make a cutout of any size, maybe not points whatever super accurately, but we in theory could make it of whatever size we actually needed. So we do want that actual smooth curve there. Part D, what is different about your graph in this problem when compared to others you have seen in previous courses? So you've probably seen a lot of parabolas, which is just kind of that singular curve shape. This has that extra little bump on it. So this is a cubic function, which is why we are seeing that kind of additional part to it. And then lastly, we're continuing to find as many other connections as you can among the models in the table. We've kind of gone over that, so I think we're doing pretty good. So that's actually going to be it for today. So there's another part of the homework, and then tomorrow we're just going to kind of wrap a few things up and then do another bit of homework. So that should be a much lighter day for us. So today's homework is 65 through 71. I will see you guys next time.